for today. So as always, I'll make sure to record the stuff that we're going through today. And this video, I would guess out of all the stuff that we've talked about so far, this would probably be the one that you'd be most wanting to return to. Because like I mentioned, we are going over some kind of tricky stuff today. And we're going to be doing a whole lot of examples of the different types of reactions. And so if you want to go back and see this video again, it'll be posted right here in the balancing chemical equations section of the Zoom class videos on the Google Classroom. But if we go down to the actual week 6, so we are in the 6th week, guys. We got this week, next week, finals week, and then we are done with term 1. Crazy, crazy, crazy times. All right. So for the notes today, not only did I put in the slideshow notes that we're going to be going through together in a little bit, I also posted a couple of other YouTube videos that some other people have made about this very situation, this very type of balancing these chemical equations, because seeing lots of examples tends to help people kind of figure out what exactly is going on. I'll go through a few today, but if you ever want to see more examples and see some people who maybe do it a little bit differently than I do in a way that works better for you, you can check out these YouTube videos that are posted with the notes in the balancing chemical equations notes section. All right, and with that, let's talk again about our chemical equations or our chemical reactions. Give it a second to load really quick. All right, sweet. All right, balancing chemical equations, making sure that we have equal amounts of our atoms on either side of our chemical reaction. That is what we're going to be focusing on today. So just a little bit of a review. At the end of last week, last Wednesday, we were talking about our chemical reactions and how these are changes with our substances where we take one set of substances and convert it into something new. And so we talked about different ways that we can refer to the substances in our reaction. We have the reactants, which are our beginning materials, our starting substances. These are the guys going to be reacting together. And scientists give them the very clever name of the reactants. On the other side, so if we treat this arrow right here as kind of like the equal sign, instead of being an equation, it's a reaction, but arrow means essentially the same. The things we end with, the things that are produced at the end of our chemical reaction, are the products. Again, very simple, straightforward name. The products are what are produced at the end of our reaction. So we start with the reactants. They do some sort of reaction together. Maybe they give off a whole bunch of bubbles fizzing and there's light coming out. And then when that's all said and done, we end up with the products, the new substances that are created as a result of the chemical reaction they just went through. So when we were talking on Wednesday, one thing that I made a very, very big deal out of is the fact that in chemical reactions, we cannot add or take away any new or different atoms. We can only rearrange the atoms that we have. So I went through this sort of big equation, the photosynthesis equation, but just focused on some of the basic facts, which is that we have our reactants over here and our products over here. So the reactants are the starting materials of carbon dioxide and water. And our products are our ending materials. Whoop, the words got moved over a little bit. Of glucose, this sugar molecule right here, and some oxygen left over here. And one thing that I really emphasized on Wednesday is that you'll notice that on the reactant side of the equation, we have C right here. We have some O's right here and right over here. And we have some H's right here. Then, if you look over on the product side, we have some C's right here. We've got some O's right here and over here. And we've got some H's that got moved around a little bit from before, and now they're right over here. So we have C's, O's, and H's on our reactant side, and C's, O's, and H's on the product side. We didn't add anything new to the products, and we didn't take away any of the elements that were already there. We only rearranged them into a different form. Instead of the C just being paired with the O like it was before, now the C and O have some H's with it. And over here, we had some H's with our O. Over here, we've lost those H's, and so now it's just O on its own. Same atoms, same elements on either side, just rearranged into different substances. So by moving all those H's in with our carbons and oxygens, we got glucose. And by taking those H's away from the water, we ended up with pure oxygen. All right. Any questions about any of that stuff so far? All righty. So that's sort of where we ended on Wednesday. We talked about the different types of reactions, but in terms of the actual chemical equations, we just went over what the different elements are doing. Today, we're going to get into the nitty-gritty of making sure that we have the correct numbers of elements on each side of our equation. So in order to do that, we have to do something. No, sorry, I was getting a little bit in my head itself. All right. So this big guy that we were just looking at right here that has the carbon dioxide plus water on one side and the glucose plus oxygen on the other side, that is a chemical equation. So again, sort of like a math equation, only it's showing how different chemicals are reacting with each other. We use their chemical formulas and symbols, right? So we don't write out 2 carbons, 3 oxygens. We would just write C2O3, stuff like that. So you may have noticed in our photosynthesis equation from before, we have some big numbers out in front of some of the atoms and some numbers underneath the atoms. Both of these guys are going to be really important for the stuff we talk about today. But the most important numbers out of those two are the big numbers. So these big numbers have their own special name because they are so important. They are called coefficients. So a coefficient just represents how many of each molecule, how many of each compound we have in our equation. So it's the big number before the chemical symbol. So this big 6 and this big 6 and this big 6 are all coefficients. Essentially, what they tell us is that in order to have our photosynthesis equation, we have 6 units of carbon dioxide, CO2. We have 6 units of water, H2O. And when they go through their chemical reaction in photosynthesis, that gives us a single unit of glucose, that's this big guy right here, and 6 units of oxygen. So whenever a chemical symbol or formula does not have a coefficient in the front of it, that just means that we only have one of that molecule. So we have 6 waters, 6 carbon dioxides, and 6 oxygens, but only one molecule. So coefficients are the big numbers, and we're going to talk a lot about coefficients today. So remember, whenever I say coefficient, that means these big numbers in the front. These little guys on the bottom are called subscripts. So the 2 by this O, or the 12 by this H, or the 6 by this O. These guys are subscripts, and they essentially tell us how many specific types of atoms go into making one unit. So like for water, H2O, the 2 is the subscript, and that tells us that in one molecule of water, there are 2 H's, 2 hydrogens, and 1 O, 1 oxygen. Same thing with our CO2 over here. In each molecule of carbon dioxide, in each compound, there's 1 carbon and 2 oxygens. That's just what the little subscripts are referring to. How many of each atom are in our compounds? All right. Any questions about coefficients or subscripts so far? All righty. So we're starting off with the basics here, because up next is where things get a little bit tricky. So when we're writing our chemical equation, one thing that scientists have to do is make sure that their chemical equations are balanced. And what this means is that the scientists might know that certain compounds are reacting with each other, but they have to try and figure out how many of each compound are involved in a reaction. So when we're going through and balancing chemical equations, the only thing that we can do in order to make them balanced is change those coefficients. So these big 6s here in front of some of our compounds on the photosynthesis equation, those were figured out by scientists in order to make sure that we had equal numbers of each atom on either side of the reaction. So those guys can be messed with and changed around when you're balancing an equation. The subscripts cannot. The subscripts are set in stone. You cannot mess around with these guys. So making a balanced chemical equation is all about making sure that we have the same number of atoms of each element, on both sides of the equation. So if we're thinking back to our photosynthesis example, we want to make sure that there is an equal number of carbons on the reactant side and the product side. We want to make sure there's an equal number of hydrogens on the reactant side and the product side. And we want to make sure there's an equal number of oxygens on the product side and the reactant side. If we're able to mess with these coefficients to the point where we can make each type of atom equal on both sides, that is when we have a balanced chemical equation. So I'll go through a couple examples of how this works for some different types of equations, but the main process that I'm going to use is going to be the same. We're going to start off with a chemical equation, so it's already been written out for us, but all of our chemical equations are missing coefficients. They don't have anything in the coefficient spot. We're then going to check and see if our atoms are balanced. We're going to count up how many of each type we have on either side of the equation. If we're not balanced, we're going to pick some coefficients that we think will balance the equation. We'll add those big numbers in the front of our chemical symbols. And then we'll go back and recheck for atom balance. We'll go back and see, okay, now that we've added in these coefficients, did we actually end up with a balanced equation? So I'm sure you guys have a lot of questions right now. Just kind of describing the process is hard to picture. So I'm going to take you step by step through balancing a simple chemical equation and kind of show you what each one of these steps actually means. So here we have a very basic chemical equation. Mercury oxide, so mercury and oxygen are combined together into one compound, but they go through a chemical reaction that breaks them up into separate mercury and oxygen elements. So we need to see, is this equation balanced? And if it's not, how do we balance it? All right, so first things first, we're going to check and see, do we have balanced atoms already? So we'll start on the reactant side right here. We have one mercury, one Hg, and one Hg in the products as well. So in the reactants, we've got one Hg. In the products, we've got one Hg. In the reactants, we've got one O. And in the products, we have two O's. So one Hg, one O in the reactants, one Hg, two O's in the products. What does that mean? This equation is unbalanced. So our Hg's are balanced with each other, right? So we have one Hg in the reactants, one Hg in the products. So that's nice and balanced. But our oxygens are not balanced. We have one oxygen on the reactant side. So as a reminder, this is the reactants, this is the products. One oxygen on the reactant side, but two oxygens on the product side. These numbers are not the same, so our chemical equation is not balanced. All right, so what are we going to do about this? Well, like I said, the only thing that we can do is change the coefficients, change putting a big number in front of some of these atoms. All right, we cannot just go in and put a small 2 by the oxygen and be like, oh, there we go. Now we're all balanced. That's no. You can't do that. You can only add coefficients, only add the big numbers in front. The subscripts, whether there are 2 or whether they're not there and they just mean 1, those are set in stone. We cannot do anything with those. So let's think about a coefficient to change. Well, we have 2 oxygens on the product side. And so maybe we can make it so we have 2 oxygens on the reactant side as well. And maybe that will balance our equation. So we can add a 2 to the reactants to try and balance our oxygens. So we put a number 2 coefficient in front of our HGO molecule. But since Hg and O are bonded together in the reactants, so these guys are next to each other because they're sharing a chemical bond, right? These guys are glued together, essentially. When we put this 2 here, it applies to both elements in this chemical bond. So we end up with the 2 applies to the Hg as well as the O. So now, instead of having 1 Hg and 1 O in the reactants, we have 2 Hgs and 2 Os in the reactants. So down here, all I did was crossed out the 1 and put a 2, because that's what we have now. Crossed out the 1 that was there before and put a 2. So now, our O's are balanced, right? We have 2 on the reactant side and 2 on the product side. Yay! Happy days, we did it. But wait. When we made there be 2 oxygens, we also made there be 2 mercuries, 2 Hgs on the reactant side. But there's still only 1 Hg on the product side. So now these guys are not balanced anymore. We have balanced oxygens, which is good, but we made our mercuries unbalanced. 2 in the reactants, but 1 in the products. So we have to do something in order to make these mercuries balanced. We can't take away this 2 because we need it for the oxygen. So maybe we can do something to the mercury, the Hg, in the products. What if we change the coefficient on this Hg to be a 2? Now, by making this 2 right here, adding that guy right in, now we have 2 Hgs in the reactants and 2 Hgs in the products. So these guys are balanced. We've got 2 O's in the reactants and 2 O's in the products. So these guys are balanced. So now we have a fully balanced chemical equation. 2 HgO yields 2 Hg plus O2. We have the same number of Hgs on both sides and the same number of O's on both sides. We have a fully and complete balanced chemical equation. All right. Now I promise we will do some more examples of this if you're still a little bit confused. But is there anything jumping out at you right now that you have questions about? Anything that you didn't quite understand how I got to this point?
I guess with more examples, Mr. Stanley, I can probably
Oh,
understand
yeah.
a little bit more because I'm a little confused.
No worries. We'll definitely do more examples. Like I said, this is probably the trickiest thing that we cover in IPC this year. All right. So we'll definitely do some more examples in a second. One quick thing that I wanted to mention before we do get to more examples is that if you ever put a coefficient in front of an atom or a compound that has a subscript, the little number, you're going to multiply the coefficient by the subscript in order to end up with your final number of atoms. So if we change the coefficient of this O2 to be 3, then we would do 3 times 2 gives us 6 O atoms, 6 oxygen atoms. It's essentially saying that before we had 2 O's that were bonded together, and that's it. But when we put that 3 coefficient in there, we're essentially saying that we have 3 O2 molecules. And so 3 O2 molecules gives us 1, 2, 3, 4, 5, 6 total O's. Same thing down here with water, H2O. If we have 4 H2O molecules, then in order to figure out how many H's and O's that we have, we would do 4 times 2 gives us 8 H's, and the O doesn't have a subscript, so there's just 4 O's. So whenever you have a coefficient on a compound with some subscripts, you multiply. All right. So that's pretty much all we're going to be doing in terms of math when it comes to balancing these equations, is either adding coefficients or multiplying by the subscript. You should never be subtracting or doing any sort of division as you're going through.
I had a question.
Yes.
Didn't you say if it didn't have a coefficient that you put a 1 in front of it?
You don't have to put a 1. It's sort of like the 1 is implied. So like if we just have a single H2O thing as part of our chemical equation, let's say we're breaking it down to H's and O's, then if there's no subscript out or no coefficient out there, it's sort of like there's an invisible 1. And so it's just saying that, okay, we start off with just one single H2O molecule. So we just write down H2O. But if we want to add in any extra H2Os, that's where we'd have to write in like a 2. That's awful too. Write in the 2, and that coefficient would tell us, okay, now there's more than one H2O molecules. There's 2 or there's 4, however many that we have to end up adding. All right, did that kind of help answer your question?
Yes, I got you. Thank you.
All right. So you don't have to write in a 1 for the coefficient. You can just leave it blank if there's only one of those compounds that you need. All right. So with that being said, let's do some more examples of these equations. There we go. Make sure. Awesome. So, nope. So I'm actually going to pull a couple of these examples straight from the assignment that got posted today. So the first example will be the actual example equation that it shows in the assignment. But then I'll pick out one or two other ones as kind of a bonus for you guys being here on the Zoom call. So let's see, our first example, we have Mg plus O2 gives us MgO. So we have a simple reaction here where before the Mg and the O2 were separate elements, but then through this chemical reaction, they get bonded together and become the compound MgO. So the first thing that we have to do is figure out how many elements of each type are on the reactant side versus the product side. So in the space below here, I like to write out my little table. So we have Mg's and O's in the reactants and Mg's and O's in the products. So I look over at my reactants and I see it looks like we have one Mg atom to start with. So I'll put a 1 right here. And 2 O atoms to start with. So I'll put a 2 right here. Look over in my products and we have 1 Mg atom in our compound over here and 1 O atom as part of that compound. So 1 Mg and 1 O in the products, 1 Mg and 2 O's in our reactants. So this is not a balanced equation, right? Our Mg's look like they're balanced to start off with, but our O's are not balanced. We have 2 O's in the reactant side, but only 1 in the product side. So we don't have a balanced reaction. So we have to start adjusting our coefficients to try and make it more balanced, try and make these numbers equal to each other. So I noticed that my O's are the ones that are unbalanced. So that's where I'm going to try and fix things first. We have 2 O's on our reactant side, but only 1 O on our product side. So I'm going to try and make these balanced and both be 2. So I can change the coefficient of MgO over here to be a 2. So that's our coefficient. So now, success. We have 2 O's on the product side, right? the 2 goes to each one of these atoms when we're doing our counting. So we have 2 O's. Awesome. When I add this 2, it also makes it so there's 2 Mg's as well. So now instead of having 1 MgO, we have 2 MgOs. So there's 2 Mg's and there's 2 O's. So now our O's are balanced. Yay, we did it. That's what we were trying to do. Awesome. But we can't go home yet. Our Mg is now no longer balanced. We have 2 on the product side, but only 1 on the reactants side. So I say, well, we have the 2 over here, and I don't want to mess with this because our O's are already balanced. So maybe I can make the reactants Mg balance with our products. So I'm going to try slapping a 2 down here as well into the coefficient. So now we have not 1 Mg, but 2 Mg's on our reactant side. So now I'm going to count again and make sure that I got all my counting right. We have, thanks to this coefficient, we have 2 Mg's on our reactant side. And we still have 2 O's on our reactant side, just like we started. Over here on the products, we have 2 Mg's and 2 O's, thanks to our coefficient out front here. So I'm pretty sure I did my counting right. Now let's check and see if things are balanced. 2 Mg's on the reactant side, 2 Mg's on the product side. So our Mg's are balanced. That's good. 2 O's on the reactant side, 2 O's on the product side. So our O's are also balanced. So we have a completely balanced chemical reaction now. We have fully balanced the equation. 2 Mg plus O2 gives us 2 MgO molecules. Our Mg's are equal and our O's are equal. So our equation is totally balanced. We are done balancing this equation. Questions about this example? Anything that I did or any of these numbers that I got to that you're not quite sure about how we got there or where we came from?
Okay, so I just want to make for sure something. So as far as like, say like if the equation is balanced, we don't do anything to it, right? We just leave it be and check it off or put that it is balanced, right?
Yeah. So I will go ahead and tell you that on the assignment for today and tomorrow, none of the equations start off as balanced. You have to go in and make them balanced. But once you do get them balanced, then you're done. They're all set. All right, good question.
Gotcha, thank you.
Any other questions before we do our next example? All right. So for our next example, we're gonna go for a little bit trickier one because that one was pretty simple. Let's see. Okay, I like this one. This one's a good one. So our equation is N2 plus, whoa, God, man, writing and drawing with a mouse is not ideal. Okay, N2 plus H2 gives us compound NH3. So N2 plus H2 gives us NH3. So first things first, let's figure out how many of each atom are on each side. So initially I see, all right, we've got N and H are our atoms that are on either side of our equation. All right, so I'm going to ask for a little bit of input from you guys on this one. So whether you want to say it out loud or put it in the chat, whatever works for you. But I'm going to be asking you guys questions as we go along to kind of get you to help me fill in what we're doing. So let's start on our reactants side. So how many N's, how many nitrogens do we have in the reactants?
2.
2, exactly. So we've got 2 N's in our reactants. How about H's? How many H's do we have in the reactants?
2.
2.
Bingo. 2 H's in the reactants. Good. Now let's switch over to our products. How many N's do we have in the products?
1.
1.
Exactly. 1 N in products.
3.
And then how many H's? Yep.
3
On the
H's.
ball. 3 H's. All right. 2 N's and 2 H's in the reactants. 1 N and 3 H's in our products. So very obviously, this is not a balanced reaction. It is a very unbalanced reaction. Our N's are not equal to each other. We have 2 on one side and 1 on the other. That's no good. Our H's are also not equal to each other. We have 2 H's on one side and 3 H's on the other side. That also is not balanced, not equal. So we've got some work to do. So I usually like to try to start with what seems like it'll be the simplest thing to fix, and trying to balance out an H2 molecule over here and an H3 molecule over here. That seems kind of tricky and confusing to start with. Let's start off with balancing our N's because we've only got 1 and 2. That's a little bit simpler. So we have 2 N's in our reactants, but only 1 in our products. So what could we do on the product side to make it so that we have 2 N's instead of 1?
Add 1.
So how do we add another N?
By putting a 2 in front of the N?
Exactly. So if we change this coefficient to a 2, let's see what that does. The 2 applies to the N first. So we have 2 N's now. Our 2 also applies to our H's. So what happens when we have a coefficient 2 out here at front and a subscript of 3 with our H's over here?
You multiply it?
Multiply, bingo. So how many H's do we end up with if we multiply the 2 and the 3?
6.
6. Awesome. So when we put this 2 in here, we get 2 N's and 6 H's total. So now let's check. Our N's are balanced now. So that's good. That's a good sign that we might be on the right track. So we have 2 N's in the reactants and 2 N's in the products. So that's good. That's nice and equal. but our reactants are still unbalanced. That did not solve our H problem. We still have 2 H's in the reactants and 6 in the products. So we already messed with the products in order to get our ends to balance. And so I don't really want to do that again, because we'd only make this number bigger and bigger. And we don't want to do that. We want to make our number over here match up with the 6. So we have our H2 right here. And like I said, we can't do anything with our little subscripts 2 down here. That guy is set in stone. So what could we do to the coefficient out here that would make us get up to 6 H's?
Put a 3 in front of the H.
Hey, Tasha has nailed it. So if we put a 3 right here, again, since we have this script, we're going to multiply. So we do 3 times 2, and that changes our H from a 2 to a 6. So first, let's double check and make sure that we've been counting our atoms correctly. So we've got, on our reactant side, we still have 2 N's like before, and we have 3 times 2 gives us 6 H's. On our product side, we have 2 N's, and 2 times 3 gives us 6 H's. So I'm pretty sure I've counted that right. And now let's check and see if we're all nice and balanced. We have 2 N's on the reactants and 2 N's on the products. So that is indeed all balanced. We have 6 H's in the reactants and 6 H's in the products. Those are equal to each other. So the H's are balanced. Our N's are balanced. Our H's are balanced. So now we have a completely balanced chemical equation. N2 plus 3H2 yields 2NH3. That is our final answer, our final equation. So we figured out how many atoms that we started with. We tried to balance one set of atoms and then checked how many we had. That caused an issue with the H's after we balanced the N's. So then we went back to the reactants, messed with our H's and the coefficient there, and then determined that we had fully balanced the chemical equation. So by changing our product coefficient to a 2 and the H coefficient in the reactants, 3, we ended up with our fully balanced equation with the same N's and the same number of H's on both sides. All right. Questions? Any questions about how we balanced our N's and H's?
Okay, so Mr. Stanley, I have one thing that I was noticing, that it's like it's a line like in front of the N of the reactant side.
Mm-hmm.
And I was just trying to figure out like what was that line all about.
Essentially, I was just putting that there to say this is where coefficient could go if we had to balance it.
Okay.
So just kind of reminding you guys that if we want to put a coefficient, we have to put it in the space in front of the atom.
Gotcha.
I have no
Thank
idea
you.
what's going on.
All right. And so when you see the first assignment that got posted today dealing with balancing the equations, it gives you these little blanks in front of the atoms to fill in with the coefficients as you go along. And we'll take a quick look at that before we finish up for tonight.
Okay. Cool.
Good
Thank you.
question.
I do. Is it better to kind of start with the numbers at the bottom?
I usually try to start with whatever seems like it's going to be the easiest to balance. So like in this case, the N's were 1 and 2, and the H's were 2 and 3. And so to me, that made it seem like the N's would be easier to balance because it's easier to put 1 into 2 than it is to try and put 2 equally into 3. And so that's why I went for the N's first. So I would recommend balance what seems the easiest at first, and then kind of see where that leads you from there.
Okay.
All right. Any other questions before we do one more example?
I don't understand any of it. I can't. Can you even hear me?
Yeah, I can hear you.
I keep getting cut off and I can't read your writing. I don't know what's going on.
Oh, no.
And then your microphone keeps warping in and out.
Oh, that's a bummer. Well, I am recording this video as we're going through. So sorry that it's not coming through as clearly as it could be to you right now. But if you want, after it gets posted, if you want to go back and rewatch me go through it, hopefully the numbers and the letters will be a little bit bigger and you'll be able to hear me a lot more clearly. And after that, and this goes for anybody, if you still have questions, like you come to the Zoom and then you watch the video and you're still not really sure what's going on, please reach out to me and I'll be more than happy to set up like a phone call or a Zoom call and go through a couple more examples later on. All right, so you're always welcome to do that.
Okay, hold on. Kai, we're right here.
What was that, Carmen?
Oh, sorry, nothing.
Okay, no worries. All right, so I'll go ahead and do one more example for you guys that is a teeny bit more complicated, although hopefully not too much. Because all of the examples that we've been doing so far have had only 2 elements that we're trying to balance. But there's going to be some examples that are going to have more than 2. Okay, so here's a pretty good one. And it involves some guys that I've already talked a little bit about. All right, so final example of balancing equations. We have Na plus HCl gives us some H2 and NaCl. All right.
Is that a lowercase L?
That is a lowercase L.
Thank you.
So now instead of having 2 different atoms on each side, we have 3. Sodium, which is Na, hydrogen, which is H, sodium is Na, hydrogen is H, and chlorine, which is Cl. So I'm going to set this up just like before. We have Na, H, and Cl in our reactants. And so that means that we have Na, H, and Cl in our products. All right, so just like before, we're going to start off by going through and counting. So how many NAs do we have in the reactants?
Is it one?
Mhm. Just the one NA. And then how many H's do we have in the reactants?
One.
Also correct. And then how many CLs do we have in the reactants?
One as well.
Also one. So we got one of each, one Na, one H, one Cl. Now, if we switch it over to the product side, how many NAs in the products?
One.
One, exactly. Very good. How many H's?
Two.
Yeah, two H's. And how many CLs?
One.
One CL. Very good. All right. So we're so close to being balanced, right? Our NAs are balanced, our CLs are balanced, but that pesky H has that 2 over here. And so our H's are not balanced. So we have to do something about this H situation. Unfortunately, we can't do anything about the subscript on this guy. He is locked in place. We can't just like erase it and pretend like it's not there. That's not how it works. We have to deal with it the way that it is. So if the H's are the only thing that's as unbalanced, then that should be the first thing that we try to go in and balance, right? Our NAs and CLs we don't have to deal with right away. So if we have one H in the reactant side and two H's on the product side, what can we do to our H's?
Do we add a 2 on the reactant side in front of the H?
Mm-hmm. So in front of our HCl molecule, we can change this coefficient to 2, just like that. So now we have 2 H's. So yay, that's good. That seems like it fixed things. But we also have that putting that 2 there gives us not 1, but 2 CLs as well. So now our H's are balanced. So that's good. That's what we're trying to do. But by doing that, we caused our CLs to become unbalanced, right? Now we have 2 CLs in the reactants, but there's only 1 CL in the products. So we have to go in and change some more coefficients in order to make things balanced. What can we do with our coefficients to balance our CLs?
Can we add a 2 to the other side?
NA. Yeah, that's what I was thinking.
Yep, we can add a 2 over here where this NaCl is. That's CLs are on our product side. So if we change this guy's coefficient to a 2, now we've got 2 CLs. Yay, that's what we're trying to do. And we got 2 NAs. All right, so now let's check and see if everything balances out. So our CLs are balanced, 2 on reactant side, 2 on product side. So that's good. Our H's are balanced, 2 on the reactant side and 2 on the product side. So that's good. That checks out. But whoops, our NAs have become unbalanced. We've got
unbalanced
on the product side, but only the 1 on the reactant side. So what do we need to do in order to make our reactants NAs balance with our product NA?
You
Put the
added
two in front of the NA on the reactant
Hey,
side.
there you go. Now you're getting it. If we make this guy's coefficient a 2, now we've got 2 NAs on our reactant side. So this is looking very good. It's looking like we're got everything balanced. Let's run through everything again, just to double check our accounting. On our reactant side, we have 2 NAs. We have 2 H's. And we have 2 CLs. So it looks like we counted all those, right? On our product side, we have 2 H's, just like what we started with. We have 2 NAs, and we have 2 CLs. So it looks like our counting was good on this side as well. So our CLs, we already determined are balanced, 2 on the reactants, 2 on the products. Our H's, we already determined are balanced, 2 on the reactants and 2 in the products. And now our NAs are balanced as well, 2 on the reactants and 2 in the products. So now we have fully balanced this chemical equation. 2 Na plus 2 HCl gives us H2 plus 2 NaCl. Everything, each atom has the same number on either side. So this is a balanced chemical equation. All right. Questions on this example? Any of these numbers that you're not quite sure where they came from or how we got them?
No.
I got it now, but watch my mind go blank when it's time to do it by myself.
That's okay. Yeah, that happens to me too all the time, where you're like, all right, teacher talking about it, everything makes sense, I got it. And then you look at the homework and you're like, where did all this come from? Are you sure we just talked about? Okay, so that's kind of essentially all the different types of equations that you're going to see in the assignments in the next couple days. And so speaking of which, the last thing that I wanted to do was kind of show you what those assignments are going to look like.
Before you do that, Mr. Stanley, so basically we're just adding a number, a 2 in front of the other numbers.
Mm-hmm. Exactly. So it
Okay.
won't always be a 2 like we saw when we were balancing that one with the N's and the H's. We had to have a 3 in front of that one H. But yes, all you're doing is, hold on, let me see if I can go back to the whiteboard.
So basically, like
Yeah.
how it was with the 3, we're actually looking at the number at the bottom, like where it says H2. We're actually looking for that to see what we're going to do.
Mm-hmm. Right. So
So
like
since that's a 2, we're just basically adding 2s to everything to make them all balance out. Like the other one was a 3. We added a 3 to balance everything else out.
exactly.
Okay.
So all you're going to be doing is adjusting the coefficient. So adjusting the numbers in front of our different chemicals in order to make everything balanced. In this case, we just had to figure out, based on going from balancing the H's with the 2 to balancing CLs with the 2 to balancing the NAs with the 2. And that's kind of the path that it led us on.
Okay.
Just like with that last example, we had the H2s that we had to put the 3 in front of. But we did that in order to make them balanced with the H's on the other side of the equation.
Okay. Gotcha.
All right. So if we look at how your next couple assignments are going to be set up, make sure you guys are seeing. Yep, looks like it. Okay, good. So the assignment that got posted today looks like this. We've got sort of an example of a balanced chemical equation in this box right here. And it gives you sort of an outline of the steps to do in order to balance these equations. And so on this first worksheet, there's 4 equations for you guys to work on balancing. And it's set up exactly like we did in the examples today, where you have your different elements listed out under the bottom. And then you have your basic equation going across the top with a space in front of the molecules to change the coefficient. So like if you want to change this one to a 2, or it'll actually be better if it gets changed to a 3. That's where you'll be adjusting the coefficients. And so for each one of these equations, you'll work through the steps just like we did today. Start off by figuring out how many of each atom that we have. So like for a quick example, in the first equation, first equation up here, we have 1 Ca. We start with 2 O's. And then on the product side, we start with 1 Ca and 1 O. Whoops. Looks like our oxygens are not balanced. And so then you'd go through the steps of adjusting the coefficients in order to balance the equation. So then you'll do that same thing for the other 3 examples, one of which may look a little bit familiar from earlier. So there's 4 ones on the worksheet that got posted today. Again, since all you guys are awesome and came to the Zoom call, you already got your attendance credit for today. So if you do not get this turned in by the end of the day today, that is totally fine if you want to take some more time to work on it. If you do get it finished by the end of the day today, then the next assignment that's going to be posted up tomorrow. So we were just looking at the Monday assignment right now. And then tomorrow's assignment, the Tuesday assignment, is basically sort of a streamlined version of the Monday assignment. So it doesn't have the big spaces in front of each compound, and it doesn't have the area underneath where you have to keep track of the atoms. You can still do that if you want. If you just hit enter and then want to keep track of the different atoms down here, that's totally fine. You can do that. Or if you feel comfortable at this point of doing it in your head or writing it down on a scratch piece of paper and then just putting in the coefficients for your final answer on here, that is totally fine as well. So a couple more examples or a couple more problems on tomorrow's homework, since we don't have a Zoom call and we've already gone over the notes. So you should have everything you know to need to get started once this gets posted tomorrow morning. The one thing I will say about the assignments is that since there are all these different steps and changing up the coefficients as you go along, I wasn't able to get these guys converted into a Google form that I know a lot of you guys have been doing and really like to do. Since this is a little bit more complicated and it's not just like a short answer or a multiple choice answer, unfortunately, it is just as the normal Google Doc that you can go in and edit, just like you saw me doing. Or if you don't really like working in the Google Docs, remember that you can always write your answers down on a piece of paper, especially if you like working things out on paper a little bit more than just typing away on the computer. Get your answers written down there take a picture of it and then either upload it on the Google Classroom or send that picture to me. That is also a totally valid way of turning in your work for these first 2 assignments this week.
Mr. Stanley,
Yes,
when
ma'am.
since you said you wasn't able to do it like how you usually do for the Google, I know on one of the ones that I did, I was able to do, when you go in there, you're still able to do like break it down on there if you transfer it. So you said you weren't able to do it on that one.
So yeah, so for this one, I wasn't able to make like a Google form like the one
Oh,
I normally do. So I wasn't able to make a version that.
oh, for that.
Version. Yeah, that's what.
Oh, okay. Oh, okay. Yeah, no, I don't like that one. I like that one. Okay, gotcha.
That's fine.
Okay.
So yeah, so if you open up the Google Doc, you can still go in, and everybody got their own copy of the Google Doc. So you can go in, and just like I was doing earlier, you can type in it and add your own numbers and change the coefficients that you need to in order if you want to submit it through the Google Doc. But I know that for a lot of people, they like working on it on on their own sheet of paper because that way it doesn't get all the formatting kind of twisted around like it sometimes does on the Google Doc.
Okay, and you said, Mr. Stanley, how are we? Because I'm usually doing Google Forms. And me, myself, I like that better. So how do we submit the Google Docs, is it?
So, yep. So after you finish, you go through and you figured out all your answers. If you go back to the assignment, for me, it's not going to show up since I'm a teacher. But when you go to
You're actually gonna like it better.
It'll show up like there's a button up here that'll say like turn in, or it's either turn in or submit. I forget which one it says. I think it's
okay.
Turn in.
Your Google Doc is always saving itself as you're going along. So once you're finished with the Google Doc, you just go back to the classroom and hit turn in. And then that'll let me know that your Google Doc is ready for me to look at and see how you did.
Oh, okay.
Good question.
Cool. Thank you. Thank you.
But you also said that if we do it on the paper, we can also email it to you too? Okay.
Yep. So just take a picture of your work and then you can text it to me. You can email it to me. You can upload it to the Google Doc, whatever works best and easiest for you. As long as you do the work and get it turned in to me, I don't really care what it looks like. All right. Oh, Thelma had a quick question. So Thelma, yes, we cannot mess with those subscripts. So those little numbers on the bottom of the atoms, you cannot touch those or do anything with those. You can only mess with the coefficients at the front. You can only add and change those coefficients. So the coefficients and the subscripts will interact with each other. When you add a coefficient, you multiply by the subscript. So the big number gets multiplied by that little number. And that's how you figure out the total number from there. But you cannot go in and change the subscripts yourself. You are stuck with those ones.
Okay, thank you.
No problem. All right. Any other questions about balancing the chemical equations or working through the homework, getting stuff turned in, anything like that that you're still a little bit unsure of or have questions on?